Introduction. Packed distillation column is an equipment used in a distillation process of vapor-liquid mixtures. The feed entering the column consists of components with different volatilities. The feed enters from the middle of the column and liquid phase in the mixture flows down the packing while the vapor flows upward through the column, leaving the column from the top. Volatility is the main concept utilized in the packed distillation column. The less volatile component in the mixture transfer from vapor phase to liquid phase, leaving the column at the bottom. Therefore, component that is most volatile in the mixture leaves as vapor in the top. Packed distillation column provides large surface area for vapor-liquid contact, hence high effectiveness of the column. Packing is used due to its ability to improve separation as it lowers the pressure drop across the column compared to when plate or tray is used. In a vacuum condition, packed bed distillation column works very best when there is a low pressure drop. The efficiency of batch packed distillation unit can be evaluated using the height equivalent theoretical plates HETP. There are some special features on this unit. The first one is direct heat input into the evaporator using cartridge heaters. The second one, silver-coated and vacuum jacket column minimizes heat loss to the surroundings. And the last one is the vapor sampling and liquid sampling on the bottom and top to determine the practical separation behavior of the particular mixture. This experiment is divided into two parts. The first part, the batch distillation, is carried out at total reflux, and the objectives are: the first one, to determine the height equivalent theoretical plates HETP at total reflux, and the second one is to determine the effect of liquid and vapor loading on the HETP at total reflux. For the second part of the experiment, the batch distillation is carried out at constant reflux. The first objective of this part is to operate a batch distillation unit at a constant reflux. The second one is to examine the change in top and bottom composition and the height equivalent theoretical plates HETP over time in a batch distillation. And the third one is to carry out mass balance calculations on the distillation unit.
Before we start the experiment, we have to prepare the refractive index versus composition plot. In order for us to prepare the refractive index versus composition plot, we have to prepare 13 solution of ethanol and water. This 13 solution have different concentration of ethanol.
For the first experiment, we want to take the sample of 5 different heating power. For an example, for first heating power, after we set the heating power to 70%, we wait until the T101 and T102 temperature stable. After that, we take the sample of the distillate and bottom, and then we can change the heating power to the next heating power with 5 different heating power, which is 20, 40, 80 and 100. Okay.
For experiment B, what we did is we fixed the power to 70, right? And we wait for the temperature to stabilize, so there's no fluctuations that's too big. After that, we turn on the electromagnetic reflux divider into auto, and we wait for intervals of 10 minutes to take the top and bottom products to measure the refractive index.
Jangan buka. Tak pandai. Ya, buat dulu. Dah.
Lepas tadi yang kira-kira.
Ada.
After we collected the sample from the top and the bottom, we have to compute the refractive index by using the refractometer. First of all, we have to take some sample and then put it here. We have to make sure it is enough. Then close the lid before you push the start button.
Hi, my name is Dinesh Nadraja and we are going to discuss the potential errors and how to overcome them. There are many errors that may occur during the duration of the project, and we have to keep an eye out to avoid or mitigate the severity of the errors. The first error we may encounter is refractometer instability. The refractometer may already contain moisture which will inevitably cause errors in the result, as the refractometer is a very sensitive measuring device. To overcome this, the inner part of the refractometer have to be rinsed with water and wiped with a clean tissue to ensure no previous sample or dust remains in the chamber. We should also calibrate the machine with distilled water before taking a reading. We should also look out for time discrepancies between recording values for the distillate and bottoms. There needs to be a vigilant timekeeper that sets the timer and notifies everybody to collect the samples and record the results when the time comes. The volume of ethanol and distilled water should be measured accurately as to not obtain faulty data. The mixture must also be mixed properly when measuring the volume of samples or distilled water or ethanol. The eyes have to be perpendicular to the scale as to record reliable data.
Before we start our experiment, we have to prepare a calibration curve. In order for you to prepare a calibration curve, first you have to calculate the mole fraction of ethanol and water. Then, plot a graph of refractive index versus mole fraction of ethanol. This calibration curve will be further used to calculate the mole fraction of ethanol by plugging in the value of refractive index in the straight line equation, and you rearrange the equation to get the mole fraction, which is X.
Now I will explain to you about result. In this experiment, we have two parts, which is experiment 1 and experiment 2. In experiment 1, for batch distillation at total reflux, our objective is to determine the height equivalent theoretical plates, HETP, at total reflux. Based on table in Appendix B, we need to find the value of temperature, refractive index, and mole fraction for distillate and bottom product. And we need to find the value for each heater power at 100%, 80%, 60%, 40%, and 20%. So, by using the equilibrium graph, we managed to get the linear equation, which is y equal to 0.0253x plus 1.3454. So, by substitute the value of y, which is refractive index, into this equation, we managed to get the mole fraction, which is x. After that, we need to plot the graph of theoretical stages at each heater power. This is the graph of theoretical stage at 100% of heater power. And next is the graph of theoretical stages at 80%, 60%, 40%, and 20% of heater power. So, after we plot the theoretical stages graph, we can get the value of HETP by using the formula of actual column height divided by number of theoretical stages. Our actual column height is 1100 mm. So, by dividing by number of theoretical stage, we managed to get the HETP value. And after that, we need to plot the graph of HETP against heater power. So, this is the graph of our HETP against heater power. So, that's all from me.
For part 2, first, we have to draw the SY equilibrium diagram. The equilibrium curve can be plotted using the equilibrium data provided in the lab manual, and we also have to draw the 45-degree line. We have to indicate the value for XD, which is the mole fraction at the distillate, and XB, which is the mole fraction at the bottom. Then, using McCabe-Thiele method, we have to determine the number of stages. After you obtain the number of stages, you have to calculate for the height equivalent theoretical plate using this formula. So, this is basically the results that we obtained based on the HETP calculation. Then, plot a graph of height of equivalent theoretical plate versus time. After that, we have to calculate the number of mole of ethanol left in the distillation column. Before that, we have to calculate the difference between mole fraction of ethanol at distillate and bottom. Then, you divide 1 by the difference between mole fraction at distillate and bottom. After that, you plot a graph of 1 divided by difference between mole fraction at distillate and bottom versus mole fraction at bottom. So this is basically the graph that you obtain after the calculation. So this is basically the Rayleigh equation whereby we can calculate the number of mole of ethanol left in the distillation column. The integral term can be evaluated by calculating the area and the graph, and we plug in the value into the equation to get the number of mole of ethanol left in the distillation column. Lastly, we have to perform the mass balance and the component balance to calculate the initial mole fraction of the ethanol in the distillation column. So this is the formula for the mass balance, whereby F is the total number of mole entering the distillation column, D is the total number of mole at the distillate, and B is the total number of mole at the bottom. So for component balance, X0 is the mole fraction of the ethanol at the feed, XD is the mole fraction of ethanol at the distillate, and XB is the mole fraction of ethanol at the bottom. So we have to plug in all the values and we calculate for X0.
As a conclusion, packet bed distillation column can be described as an equipment used in a distillation process of a vapor-liquid mixture. Packet bed distillation column, one of the type in distillation used in chemical industry. We have choose petrochemical industry based on synthesizing ethanolamine based on our experiment. We also have done economic analysis to estimate the profit made in a chemical plant. This analysis based on estimation by equipment that being used in industry. Profit have been made in industry is 146 million USD per year. In this experiment, we want to study the significance of the packet bed distillation column in the synthesis of ethanolamine from the reaction between ammonia and ethyl oxide distillation that used in industry. We have two parts, which is part A and part B. In part A, we want to determine the height equivalent theoretical plate and also the effect of liquid and vapor loading on the HETP at total reflux. In part B, we want to determine the height equivalent theoretical plates and also the effect of liquid and vapor loading on the HETP at constant reflux. In result of part A shows that the number of theoretical stages remain constant. Meanwhile, the result part B shows that theoretical number of plates for each sampling time are the same, which is one plate only. That's all. Thank you.